Hex meshing is super important to analysts because it aids in solution convergence. However, sometimes hex meshing can be challenging. In this video, I'm going to go through my techniques of how I hex mesh troublesome parts in HyperMesh. The part I'm going to model is a bracket with holes in two planes, and because hex meshing is done through extruding elements in a single plane, this is a classically difficult geometry to hex mesh. I will first turn on the mappable visualization, which tells me if a body can be hex meshed or not, as well as creating a new component which I will use to create my hex mesh. With these options turned on, I can begin my process of creating a hex mesh for my bracket. I first notice that the model is symmetrical, and because of HyperMesh's element mirroring, this means I can reduce the size of my model by creating symmetry cuts. Cuts in HyperMesh are done via the split tool found under the topology menu. In hex meshing, you will use the split tool a ton. After my symmetry cuts, I organize the new symmetry solid into the new component I just created. I always try to create a new component in hex meshing because it helps me organize my geometries, as it allows me to put all the new splits in the solid into a new component, while retaining the original component geometry if I need it. If we look at our new split solid, we will see a yellow color, which means the body is mappable and able to generate a hex mesh. So let's create the hex mesh via the solid mapping tool under the 3D menu in HyperMesh. After creating the hex mesh, we can see the elements distort near the bigger hole. This isn't ideal, and we'll have to make some further splits in our solids to have a more uniform mesh density. Since my original mappable geometry had distorted elements when I created the hex mesh, I need to create splits on the solid geometry. The general rule of thumb when you split solid geometry is to look at any major geometry changes for a part. In this case, I want to isolate the whole geometry on the left as a solid, and then split up the larger diameter hole into additional solids. I use the split command like I used for the symmetry cuts. After these splits, you will see the bracket has two mappable regions and one region showing as non-mappable. Here's my next tip. With especially hard parts, hex mesh in portions rather than all at once. In other words, I'm going to first hex mesh the left-hand solid and then the right-hand solid. After doing this, you will see that the previous red unmappable body will now become mappable, and we can create the hex mesh for the final solid piece. At this point, my model is now fully hex meshed, but you will notice that one side of the larger diameter hole has more elements than the opposing side. With HyperMesh's mirroring option, I can clean this up if I decide to do so. Note this isn't necessary, but I'm going to show you how to do so. To do this, select all the elements on the right-hand side with the less dense mesh and delete them. Then highlight all of the hole elements on the left-hand side and select mirror elements via the cutting plane. After this command completes, I will see the same dense mesh on the right-hand side of the part, which shows the power of mirroring in HyperMesh. I now just need to mirror the rest of the bracket using the same mirroring command. Mirroring can be done by selecting the elements and then selecting the appropriate plane and snapping to the node associated with it. With the entire part now meshed, I now need to ensure that all nodes are properly equivalenced. I can equivalence via the equivalence command under the validate menu. Through following a few simple tips and using the split tool in HyperMesh, I was able to easily generate a hex mesh for a part that initially appeared like it couldn't be hex meshed. Try these tips out the next time you're hex meshing a part. If you have any more questions on hex meshing in HyperMesh, reach out to us at www.trueinsight.io.